In this video I'm going to talk about composite functions. Composite functions are sometimes known as a function of a function. The example here I'm going to use is h of x equals f of g of x. Now, in order to evaluate a function of a function, we start from the inside out. So here we'll start with g of x, then take f of g of x. So we start with g of x first, then we take f of g of x. Let's have a look at an example. In this example, f of x is equal to 2x squared plus 1, and g of x will be equal to 2 minus x. So f of g of x means we substitute into f the value we have for g. So g is 2 minus x, we substitute that for the value of x in f, and we get f of g of x equals 2 outside of 2 minus x all squared plus 1, because g is 2 minus x. Let's evaluate that now. That's equal to 2 outside of 4 minus 4x plus x squared plus 1. Taking the 2 through the brackets, that's 8 minus 8x plus 2x squared plus 1, or 9 minus 8x plus 2x squared. If we take the functions the other way around, g of f of x, in other words, if we operate f on the function first, then if we just quickly look back at g up the top of the page here, you can see that g of x is 2 minus x. So we're going to substitute f of x for the value of x in g, and that gives us g of f of x equals 2 minus 2x squared plus 1. And if we evaluate that, we get 2 minus 2x squared minus 1, or 1 minus 2x squared. Another way of looking at these functions is to think of the functions as a type of machine into which you throw numbers in the top, and the function acts on those numbers and spits them out at the bottom. So let's take g of x for example. Here g of x is equal to 2 minus x. If we throw x into the top of the machine, out of the bottom of the machine comes g of x. Now that g of x feeds into the next function, which in this case is f of x, and f of x is 2x squared plus 1. So out of the bottom of that machine we get f of g of x, we get the composite function. For example, let's put a 2 into g of x. Out of the bottom of g of x comes 2 minus 2, or 0. 0 feeds into f of x. F of x is 2x squared plus 1, so it takes 2 times 0 plus 1, and the result coming out the bottom is plus 1. Now we can think of the whole machine as being h of x. H of x is exactly the same thing as f of g of x, but the composite function, remember we worked out before, was 9 minus 8x plus 2x squared. So h of 2, if we put 2 into the top of the machine, out of the bottom of the machine comes 9 minus 16 plus 8, or 1 as before. So you can see h of x is the equivalent function of f of g of x. And similarly we can think of the functions taken in a different order, g of f of x. This means that we're putting f as the first machine, so that we drop x into f firstly. Out of the bottom of the first machine comes f of x, that feeds into g of x, which in this case is 2 minus x, and out of the bottom of that machine comes g of f of x, or h of x. And we can think of the whole two machines together as being h of x, the equivalent of g of f of x. So you can see it's important as to which machine comes first, and we start on the inside and move outwards. Let's have a look at an example going into this machine. If we put 3 into f at the top, out of the bottom of f comes 2 times 3 squared plus 1, or 2 times 9 plus 1, that's 19. 19 feeds into g of x. Out of the bottom of g of x comes negative 17. So we put 3 in the top, out the bottom comes negative 17. And as before we worked out h of x is 1 minus 2x squared. If we put 3 into h, then we get 1 minus 2 times 3 squared. It's equal to negative 17, exactly the same result. So in summary, when looking at composite functions, the order of the function is important. We start with the inside function and we move outwards to produce our composite function h of x. Or we can think of the functions as two machines, one which operates on the number first and the other which operates on the number secondly. And the order in which those machines come is important. Generally speaking, g of f of x is not the same as f of g of x because the machines, if you like, are in a different order.
For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.